Welcome to this lesson on centripetal force. In this video, we will explore one of the most important concepts in circular motion. Centripetal force is the force that points toward the center of a circle and keeps objects moving in circular paths. Understanding this force helps us explain everything from how cars turn corners to how planets orbit the sun. Let's dive in and discover what makes circular motion possible. So what exactly is centripetal force? Centripetal force is a force that acts on any object moving in a circular path. The key characteristic of this force is that it is always directed toward the center of the circle. The word centripetal actually means center-seeking. Without this inward force, objects would simply move in straight lines according to Newton's first law. Instead, this force continuously pulls the object toward the center, causing it to follow a curved, circular path. Let's talk about the direction of centripetal force in more detail. First, centripetal force always points inward, toward the center of the circular path. This is what makes it different from other forces. Second, this force is always perpendicular to the velocity of the object. This means it acts at right angles to the direction the object is moving at any instant. Because it's perpendicular to the velocity, centripetal force changes the direction of motion without changing the object's speed. Now let's look at the mathematical formula for centripetal force. The formula is F sub c equals mv squared divided by r. This simple equation relates the centripetal force to three important quantities: the mass of the object, its velocity, and the radius of the circular path. Notice that the velocity is squared in this formula. This means that if you double the velocity, the required centripetal force increases by 4 times. This is why it's much harder to turn a corner when you're moving fast. Let's break down each variable in the formula. F sub c represents the centripetal force, measured in newtons. The letter m stands for the mass of the object, measured in kilograms. The heavier the object, the more force is needed to keep it moving in a circle. Next, v represents the velocity of the object, measured in meters per second. Finally, r is the radius of the circular path, measured in meters. A smaller radius means a tighter turn, which requires more centripetal force. Centripetal force appears all around us in everyday life. Let's look at some examples. On a roller coaster, when you go through a loop, the track itself provides the centripetal force. The track pushes on the car, directing it toward the center of the loop and keeping it on its circular path. When a car turns around a curve, friction between the tires and the road provides the centripetal force. This friction acts inward, toward the center of the turn, allowing the car to change direction safely. Here are 2 more fascinating examples of centripetal force in action. Satellites orbiting Earth rely on gravity as their centripetal force. The gravitational pull of Earth constantly pulls the satellite toward the planet's center, keeping it in orbit rather than flying off into space. When you swing an object on a rope or string, the tension in that rope provides the centripetal force. The rope pulls the object inward toward your hand, which acts as the center of the circular motion. Let's review the key points about centripetal force. First, remember that centripetal force always points toward the center of circular motion. It's this inward force that makes circular motion possible. Second, the formula F sub c equals mv squared divided by r shows how mass, velocity, and radius all affect the required force. Finally, centripetal force is everywhere around us, from satellites orbiting in space to roller coasters at amusement parks to vehicles turning on roads. Understanding this force helps us design safer vehicles, plan satellite orbits, and explain the motion of objects throughout the universe.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.